Hello, this is Wayne Delker again. And now what I'd like to do is talk to you a little about the technology journey we took in developing this exciting technology, as well as share a little of our intellectual property strategy going forward. Our real challenge, what we wanted to do was actually pretty simple. It was take a cup of rich caffeinated coffee and convert that into a great tasting decaffeinated cup of coffee within 30 seconds and a simple process of stirring. And we believe we've done that. Of course, we started looking at the commercially available approaches. And as you probably know, they're all very large-scale industrial processes where the caffeine is extracted in bulk from green coffee beans before roasting. This has several big disadvantages. One, it removes more than caffeine, which can have a very significant effect on flavor and aroma. Second, it can actually damage the coffee bean, which impacts color of the brewed coffee. Third, it really makes the supply chain much more complicated because now the producer needs to carry caffeinated beans as well as decaffeinated beans, really doubling the amount of work. And finally, and the one that's most important to us, there's no role for the consumer. The consumer does not have control of the process of removing the caffeine right before they drink the coffee. So since the commercial approach wouldn't work, we had to go to a totally different concept, which we call our point of use programmable polymer system. It allows the consumer to very simply dial down the amount of caffeine they want and really has a lot of consumer perceived advantages and really so far no downsides that we can find. So we're really excited about this technology in terms of the breakthrough products that we can develop from it. So since the commercial approach didn't work, we had to come up with a totally different way of removing caffeine. And what we did is we developed a solid phase extraction system with a polymer uniquely designed to grab onto caffeine and pull it out of the coffee solution. But before we could even develop the technology, we needed to first figure out how did we want to measure success. So we worked with many consumers to really determine these 8 design criteria that our product really needed to achieve if we were going to take it to market. The first, of course, is removing caffeine. That's kind of a no-brainer. If it doesn't remove caffeine, it doesn't work. But also important is the capacity to remove caffeine. There were a lot of polymers before us which could take out very minute amounts, mainly for analytical testing in chemistry labs. But we had to take out large quantities of caffeine from a full cup of coffee. Not an easy thing to do. The third, and the one that I'm most excited about, is improving the selectivity. We needed to be able to pull caffeine out of the coffee and leave everything else behind so that we minimize the impact on flavor, color, and aroma. Fourth, it couldn't leave a residue. We want this to be a process that just takes caffeine out, does not introduce anything new into the coffee or leave a residue. Of course, it had to work on hot beverages. It had to be cost effective because we want this to be something that the consumer can use with every cup of coffee. And there had to be no safety risks. And we looked at this as real safety risks. Of course, there couldn't be any, but also perceived safety risk. We want the consumer to be totally confident that they can safely use this system. And finally, the consumer is not willing to wait around forever. It had to work less than 60 seconds, and we ended up zeroing in on 30 seconds is the right target. So as we looked about how to go about this, there's a whole world of polymers out there. And some of the polymers that had been used in the past were aromatic polymers, acrylic polymers, and then a whole variety of other materials. And a lot of different blends had been used. And as you can see on the left chart, all of those materials of using blends of existing polymers was not able to hit all 8 of our design criteria. In fact, the 2 that were the most problematic were the selectivity, which we talked about, but also heat, being able to remove caffeine from a hot beverage. Not an easy thing to do. So we had to take this totally different approach and basically created what we call these programmable polymers that have been formed around caffeine as a template. And with that approach, we're proud to say we've been able to successfully hit all 8 criteria. We had to find what we felt was the promising region. What that turned out to be was a combination of divinylbenzene and methacrylic acid. For those of you that are chemists, you might recognize that the use of benzene, aromatic type materials, and acids is very similar to the approach enzymes use to bond very small molecules to catalyze reactions. So in some ways, there's a bit of a biomimetic approach here. So why was this promising region so small? And it's because of the trade-offs. We could either optimize capacity and then lose selectivity, or alternatively get the selectivity but not be able to take enough caffeine out of the coffee. Optimize both, well then something else fell out of bed. And it took a tremendous amount of work to figure out actually where we needed to be. We then went from our promising region down to a very tightly defined sweet spot where we've optimized the polymer composition, the chemical structure of the polymer, and also the kinetics of caffeine absorption. That's the speed at which it absorbs the caffeine, as well as the thermodynamics, which represents the total amount of caffeine that can be absorbed. By pulling all of these things together, we were successful in all of our criteria. Of course, we want to protect this investment, which literally took over a decade. And we did that in several ways. First, our first generation of technology and the concept of point of use removal of caffeine has been patented in those 2 US patents that you see on the screen. However, they're old now and they have limited life remaining. However, we've had 2 subsequent generations of technology, which we then have dramatically improved the performance of the polymer. And these materials are being patented in June of 2018. So extending significantly the length of time of our protection. Overall, our philosophy is we want to own the best technology solution for this problem, but we also don't want to stop there. We want to own the rest so that as we partner with other folks that will help us commercialize this, we actually have really good protective insulation of not only exactly what we'll do, but other possible solutions. Finally, of course, as we form our partnerships, we're using trade secrets to protect a lot of our other proprietary information that we've not put in the patents. Moving forward, as we said, lots of people have tried and we think have failed, and we think we found that unique sweet spot. We want to continue patenting all the polymer variations and improvements, which we're doing in the lab. We also want to have polymer protection of the method of use and also any articles that might come out of this using this technology. I guess the last thing to leave you with is our overall approach is we really want to be exclusive in terms of having essentially one-stop shopping for anyone that is interested in working with a system like this to remove caffeine. We're going to continue optimizing the system, lots of really good ideas in terms of where to go from here, and then continue to look at other possible systems beyond what I told you about that could actually be useful in this or other related applications. So thank you for listening, and next we'd like to talk to you about the size of the market and why we're so excited about this particular application.